And we're back to finish up 10.2. We're looking at the classwork problems on your notes. And the first question here is, how many particles are in 10 grams of H2O water? Okay, so again, we'll go ahead and write down our starting quantity, which is 10.0 grams of H2O. The question has how many particles. Using the molar roadmap, we have to go from grams to moles and then moles to particles. So to go from grams to moles, we're going to use the molar mass. 1 mole of H2O is going to have a mass of 18.02 grams. Now, how did we come up with that amount? You have 2 hydrogens at 1.008, and you have 1 hydrogen at 16.00. Go ahead and add them up, and again you have your 18.02 grams per mole. So the grams of water are going to divide out with the grams of water up top. Let me add an O here. It's not H2, it's H2O. So if we go ahead and cancel out the grams of water, top and bottom, we're left with moles of water. The question wants us to go to particles. So we're going to change moles of water into particles of water using Avogadro's number. 6.022 times 10 to the 23rd molecules of water in 1 mole. We know that the Avogadro's number goes on top because we have to have moles on the bottom so that it can cancel out with moles on top over here. And it looks like we're ready to do the calculation where we have grams canceled out, moles canceled out, we're into molecules, and so it's going to be 10 divided by 18 times 6.022 times 10 to the 23rd, and we should get 3.34 times 10 to the 23rd molecules of water. So there you go. That's how many molecules are in 10 grams of water. Now the question says, for the second part, how many grams are in 5 liters of ammonia? So we'll start with our 5.00 liters of ammonia. To go from liters to grams, you have to pass through moles. Everything is going to be going through moles. So to change our liters into moles, we got to use the molar volume. We have liters on the top, so we need to get our 22.4 liters of ammonia in the denominator. 1 mole of ammonia will go up top. The liters of ammonia divide out, top and bottom. We're left with moles of ammonia. And now we got to go to grams using the molar mass. Of course, you do have to add these up. We have nitrogen, which is 14.01, plus 3 hydrogens at 1.008 apiece. And when you solve, you should get 17.03 grams per mole. We want to have the 1 mole of ammonia on the bottom, the 17.03 grams of ammonia go on top. The moles divide out, top and bottom, and you're ready to do the calculation. 5 divided by 22.4 times 17.03, and that should be 3.80 grams. Now, let me do that in black. That's what we've been doing. 3.80 grams of ammonia. And there you go. So that's how much 5 liters of ammonia gas at STP would weigh. And the last question, what volume in liters does 80 grams of CO2 occupy? So we'll start with our 80.0 grams of CO2. First thing we need to change the grams into is moles. Carbon weighs 12.01. Each oxygen weighs 16. You have 2 of them. Add them up, and it should be 44.01 grams per mole as the molar mass of CO2. So we're going to multiply this by 1 mole of CO2. and put the 44.01 grams of CO2 on the bottom, so that our grams of CO2 divide out with grams of CO2 on top. It must be 1 on top, 1 on the bottom. And now we need to take that to liters, and we're going to use our molar volume, which is 22.4 liters per mole. So our 22.4 liters goes on top, our 1 mole of CO2 goes on the bottom. Moles divides out with moles, and we're ready to do the calculation. 80 divided by 44.01 times 22.4, and that should be 40.7 liters of CO2. If you have questions, please see me in class. We'll be doing plenty of demonstrations and discussions about this. Again, use your molar roadmap, use the units to determine what goes in the numerator, what goes in the denominator, make sure all units get divided out properly, do the calculations, and voila, you got it. We'll see you next time.